This episode of Serverless Chats is sponsored by New Relic and Epsagon. This week, I chat with Taavi Rehemagi about achieving operational excellence. This is Serverless Chats, episode number 75. Hi everyone, I'm Jeremy Daly and this is Serverless Chats. Today I'm chatting with Taavi Rehemagi. Hey Taavi, thanks for joining me.
Hey, thank you, Jeremy. Nice to be here.
So you are the CEO and co-founder at Dashbird. So why don't you tell the listeners a little bit about your background and what Dashbird does?
Sure. So I've been a developer myself for pretty much my entire life. I started coding when I was 14, and since then, before starting Dashbird, I was an employee in two different startups, and the last one I was working a lot on serverless. That was in 2016-17, which kind of led me and some of the team at Dashbird to found this company called Dashbird, and we're an operations platform for serverless workloads. We help companies who are building on serverless to achieve excellence with their infrastructures.
Awesome. All right, so we have done a number of shows about observability because observability in serverless seems to be that third-party offshoot that has been missing, right? Like there's a lot of things that AWS just didn't really tackle initially with a lot of the observability stuff. Now they've added quite a few things, but again, it's nowhere near as easy to use as some of these third-party tools like the Dashbird are. So there are obviously constant enhancements. They just launched, and we can get into this in a little bit more detail, but they just launched not too long ago this idea of the extensions API for Lambda, which allows tools like the Dashbird or whatever to have more control over the lifecycle. If you wanted to have control over the lifecycle of the Lambda function, being able to get metrics and telemetry data and things like that. But I think there's still a bunch of stuff missing, and I think you would agree with me on this, that there's more we have to do in order to understand and observe our serverless applications. So I'd love to get your input because I think, Dashbird has sort of a different outlook, or I guess a different roadmap for how you want to address the observability problems, and it's super interesting. So why don't we start there? What's missing, in your opinion, with observability in serverless?
Sure. So I think first off, observability is one thing we do, but when it comes to operating a serverless infrastructure that has, we're talking about high load, at scale environments. There's a lot going on there that we try to help companies with. And as an engineering team, if you're really building something that has, hundreds or thousands of functions, for example, and a lot of different cloud resources, then the one thing that's really difficult obviously is monitoring data and getting an overview of the activity going on across those resources and across your infrastructure. But there's also how do you detect failures and how do you get notified quickly and how do you respond to incidents and solve them. There's also keeping up with things like security and cloud posture, following best practices, optimizing for performance and cost. So the monitoring is kind of one part of the puzzle. And having been in this role where we were building a pretty substantial serverless infrastructure, there's a lot going on there. And a lot of those things, as a team, you would have to build yourself and kind of to figure out yourself and to construct strategies around how to improve. So that's really what we're trying to do for our organization. So we're trying to kind of build an abstraction level for operational practices, pretty much.
Right. So I love that because it's a more sort of holistic approach, I guess, to building a serverless. So building and managing a serverless application as opposed to just sort of being responsible for, I guess, the monitoring aspect of it. Because again, operational wise, and this is something I forget who I was talking about this to, but essentially where it's serverless or monitoring and observability in serverless is great when you get an alert that says something went wrong. but it's also really good and comforting to know that something went right, right? So like to know that events are flowing through the system, and that the SQSQs are processing correctly, and knowing that those things are working correctly, and give you that level of confidence. So I think that's really cool. So from the dashboard perspective, and again, I want to keep this a little bit more general, right? We don't want to it's not all about the dashboard, but I really do love this perspective that you have. So what is the vision in terms of being able to manage not just the monitoring piece of it, but also the operational piece and implementing those best practices? Like how do you look forward, or how do you plan a product that does that?
Yep. So when we kind of started working on dashboard, obviously it was like not, we didn't come up with this vision in the first iteration. At first, we were just building a tool to monitor Lambda functions pretty much. What that gave us early on was like hundreds of people or companies who were actually struggling with this, and after all of those conversations, I think we kind of constructed this hypothesis around what this platform should look like for like those teams that were the early adopters. And so what dashboard is today and what we're building it to be is this platform that's you can look at it in three different pillars, and I can go into those pillars if it makes sense. So the first one,
let's do that.
Sure. So the first pillar that we have is a data centralization pillar. So what we do is we connect to your AWS account without any code instrumentation. We don't use Lambda extensions or layers or kind of instrument the code at all. Instead, what we do is we discover the entire cloud infrastructure that you have and start ingesting all different types of monitoring data for those resources. So that includes things like log data, metric data, tracing data, configuration data, and really everything that the system is putting out externally. And from that external data, we're trying to understand the state of the infrastructure and to make that data available to the engineering teams to be able to search and query and to interrogate that data in all different ways. So basically, the first offering is to get everything in one place, to break down the silos between logs and metrics and traces, and to be able to look at services and activity across different services and different resources. So that's kind of the first thing that we do.
Yeah, so let's talk about that for a second. So the idea of instrumentation. So this was something right from the beginning with Lambda that you really couldn't do, right? I mean, you can't install an agent somewhere that just listens to all the activity that happens with a Lambda function. Now, we got layers, we got custom runtimes, now we have extensions API. So there's different ways that within a Lambda function, you could add some type of instrumentation. Even just wrapping the entire function in another function was one of the strategies that was used. I know some companies would read off of your Cloud Watch logs, and of course, just recently we've got the ability now to attach multiple listeners to your CloudWatch log. So there's all these things that are evolving, but you don't have the ability to instrument all of the other things that are part of that ecosystem. So your SQSQs and your Event Bridge and DynamoDB, like there are logs that are there, but like that's the thing where just adding some instrumentation to the Lambda function itself, that's a very small part, I think, of your overall serverless application, right? Yeah. So like how do you make sense of all of that log data and kind of connect all of it together?
Yep. So really early on, two things we kind of discovered was that the first thing is that Lambda is such a small part of the infrastructure, and kind of what really makes up for most of your infrastructure are things like SQSQs, databases, API gateways. So that's there's a large surface area there that's actually as important as functions. The other kind of fundamental realization was that functions are more simple than you would have code in your containers or something like that. There's a singular thing that any one function is doing usually if you design it according to the best practices. So the complexity is simple enough that it doesn't need code level instrumentation most of the time, and we didn't feel the pull of the market towards providing customers with like really low level data. So kind of that's why we took this approach, and how to kind of for us, like how we provide value for DynamoDB table monitoring, for example, or API gateways is like first of all, alert coverage to all of the resources. So if your API gateway is timing out, or if it's having like failures, or there's an increase in anything, then that's automatically discovered and kind of continuously checked for. So yeah, like really what we're trying to do is to bring the mean time to resolution across any one resource down to as small a time as we can.
So, right. And so if you're not doing instrumentation within the Lambda functions themselves, so you're not capturing, like you said, low level metrics, just the data that pours out of Lambda. I mean, obviously you've got CloudWatch metrics and things like that are really helpful. That'll give you failure rates and invocation rates and concurrency and things like that. But the log data itself sometimes has valuable information in it. But if you've ever looked, and I'm sure you have, looked at the log data that comes out of a Lambda function, I mean, it's a lot of junk, right? It's a lot of stuff that's just sort of useless. And if you think about log shipping, log shipping solutions that just take those CloudWatch logs and send them all to some other system, whether that's Elasticsearch or something like that, that is a lot of data that you're storing that, at least in my opinion, is useless, right? Like there's things you don't need to know. So how do you I guess, obviously I think your tool does this, but extract value from the log files? Because it seems to me like there's just a lot of junk in there that you don't need, and you certainly don't need to be saving.
Yeah, exactly. And that's another topic that we spend a lot of time thinking on. So the thing with managed service logs is that they are high in volumes and low in density of value. Right. For example, one API gateway request makes around like 19 or 20 log lines, and most of them are completely useless if it's a successful invocation. And honestly, the same with Lambdas as well. There's like a lot of noise. So what, like in our case, what we do is we apply pre-built filters on top of the log streams, so that if there's a code exception, if there's a timeout, there's any type of like service specific failure, then we have a filter for that, and that we automatically detect and kind of aggregate to see how it happens over time, and kind of manage that as a failure scenario. For like a lot of the kind of not so important logs, we kind of store them away somewhere in cold storage. We don't keep it in the log analytics part of our platform, where it's warm and it's expensive to retain. So yeah, I think that the important one of the important things is getting the cost down from processing the sheer amount of log data. The other part is equipping the engineering teams with the right filters and kind of right knowledge to catch those like known and unknown failures that can happen. So it takes a lot of time and effort to actually put together for each engineering team, like what could possibly go wrong in my logs and what should I be monitoring for. So that's how we approach.
Hi, everyone. I want to take a minute to thank our sponsor, Epsagon. Epsagon enables teams to instantly simplify, visualize, and understand what's happening with their complex microservice architectures. With their comprehensive, lightweight auto-instrumentation, users are able to eliminate the gaps in data and manual work associated with other APM solutions, providing significant reductions in issue detection, troubleshooting, and resolution times. Epsagon aggregates, unifies, analyzes, and correlates data from all the third-party tools you love, delivering a single pane of glass for understanding serverless, containers, Kubernetes, and more. Engineers now know when something is wrong and can immediately trace issues to root cause before they affect production. Increase developer efficiency and reduce application downtime with Epsagon. And as a special for Serverless Chats listeners, if you try out Epsagon and connect your first trace today, they'll hook you up with one of their awesome t-shirts. Check it out at epsagon.com/serverlesschats. So then, speaking about monitoring, that's another one of these pillars that you've mentioned in the past, is the idea of actually alerting. A good monitoring solution is going to have alerts. So but again, you take a little bit of a different approach, I think, to how you alert.
So like I think when we really started to acquire customers, it was after we did alerting. So at first, dashboard was just a tool that you could kind of roam around in data and look at different things. But when we started sending emails when there's a timeout or something, then that tripled the usage like overnight, pretty much. So yeah, you kind of have to send meaningful alarms, and that starts like 70% of all the use cases in our
Mm-hmm.
platform. It's just when somebody gets a notification. What we provide for our users is this coverage of whenever something goes wrong across your infrastructure that you should know about. We let you know. So we cover all of the API gateway failures, or if the latency increases for API endpoints, or if there's a delay in the queue. We manage that kind of alert setting and alert handling. So yeah, I think that the situation is that if you have hundreds of resources, each of those resources has like 5 or 6 different potential failure scenarios that can happen. So we
Right.
try to take that overhead.
Yeah, well, and I
Yeah.
think I think that's an important piece of this too, is to say, like you can set up a CloudWatch alarm that says when my SQSQ has more than 1,000 messages in flight or whatever that is that I want to send myself some sort of alert. And then you've got the ability to set like send another alert when the threshold drops to something or whatever. But I guess my question around this is, even if you know what's happening, like even if you are a serverless architect and you've been doing this for several years, like I think I could look at something like me personally and say, yeah, I know what alarms I probably want on this particular resource. But what I certainly don't want to have to do is set that up on thousands of resources and do that. So automating those alerts is one, I think, cool benefit. And I know a lot of services do this as well, but just bringing your experience to understand what the patterns are and knowing when something is a problem, right? So again, like, is there like anomaly detection, or how do you kind of set that up where or you kind of automatically set up these alerts for these different resources based off of your experience with what the right pattern for failure looks like, I guess.
Yep. So like for a lot of those complex alarms, we're looking at historical data as well and seeing if that fits the pattern. So if the changes basically over time is also a trigger condition for us. Kind of the way we look at this, like setting alarms, is that some things could be more critical than others. So we look at like API endpoints that have like error rates or high latency more over something that's perhaps more um, on the kind of downstream. Like we look at those kind of user facing things more critically. We look at something that causes a high delay or kind of affects the user experience more. Like we treat that as a more critical event than, for example, something that's like just kind of a little bit slow or abandoned or not being used. So yeah, we kind of
Right.
try to prioritize as well.
Yeah, no, I think that's super important because, again, I know it's relatively easy to set an alarm on something, but
Mhm.
understanding like because again, things change over time too. So I could very easily set an alarm that says when my SQSQ goes over, whatever, 500 messages, then I should be looking at that, or I should send myself some sort of alarm. But if that is slowly increasing over time, and historically I'm getting more traffic, so now my SQSQ is backed up a little bit more, and it's common for it to do that. Having a system that can sort of adapt and understand, I think, is crazy important. But anyways, so the other thing though about and I think I sort of mentioned this before, is about understanding patterns and knowing sort of what's the best way maybe to implement an alarm. Beyond just alarms, there's just best practices out
Mhm.
there, right? And AWS has a very good resource. It's the well architected framework, and specifically for serverless, there's the serverless lens. So I love this resource. I suggest everybody go and read this resource if you're building a serverless application, so what to do, what not to do. There's a tool that they have that actually allows you to track how compliant you are, or whether you're following these things. But it's a manual review process. It's like a matter of answering questions. So again, what's a way that in the future we can sort of ensure that these best practices are being followed without having to have a human go and keep looking at these things?
So in dashboard, not to kind of do much product placement, but when we discovered like all the types of data that we have, like if you have all kind of basically all of the monitoring data, and you have alerts set up in your platform, and kind of realize that there's this opportunity to actually run a lot of analysis on top of that. And there's this kind of a whole book or like framework around what the serverless application should look like, and kind of what are the best practices around security, around operational excellence. And we kind of discovered that actually like a lot of this we could find out using the data that we already have, and kind of build this system that continuously surfaces and kind of pushes the user towards the best practices. So yeah, today we have a collection of rules that we continuously apply and check for, and then kind of get back to you with this list of, hey, your API endpoints are not encrypted, or you're not using the right encryption in your databases, or you have something that's unused or abandoned or not tagged. And like a lot of those things we can surface and kind of push the user towards. And yeah, we're trying to automate and equip teams with the best ways of following the best practices of the industry. So that's what we're building, and kind of having quite a lot of success recently as well.
Yeah, no, I think that's really cool, because I mean that's one of those things where it's so hard. I mean, if you think about static analysis of code, and you can catch some things with that. You could look at configurations and you might be able to say, oh, the security, you've got a star permission here or something like that. But until the code is actually running and data's flowing through it and you're seeing what happens there, that's, I think it's where like the rubber hits the road there, and you can kind of see how that stuff works. So that's fascinating. Now I do have a question though, because I know best practices in serverless are really hard, and I know that AWS has their serverless lens for the well-architected framework, and they make really good suggestions. But there's always a time, at least for me, I do it quite a bit, is you have to break the rules, right? Sometimes to make something new happen. So how is your system going to deal with sort of breaking those rules when it needs to?
Like that's the constant challenge, is to keep the alarms adequate, and like not like when a user looks at this and says like, hey, I do understand why this is here, but it doesn't apply at all. And I think when we first started, alarms were going off like all over the place, to be honest. Over time, kind of we've like removed some of the more kind of the ones that are like optional. But yeah, it's not easy. I think that the other thing that we can play around with is the critical level. Like how critical is something? Like if you're,
right,
like really exposed somewhere, then you should have a high priority alert. If it's like you're not, you're not tagging your resources, perhaps that's not as important. And
right.
yeah,
Awesome.
yeah, but
all right,
yeah, I just want to say that we're never going to get to the kind of perfect 100% with those insights, but yeah.
Hi everyone, I wanted to take a minute to talk about New Relic. I know when it comes to things like observability and tracing, you're probably thinking I should talk about Datadog, Prometheus, or even OpenTelemetry. And a few months ago, I would have totally agreed with you. But New Relic did something a little out there. They literally reworked everything. They've actually been listening when people talk about blind spots, being stuck with a dozen different tools, or getting hit with hidden costs. So first, they went open source, making it so that you can actually instrument whatever you need. Then they made it so that you can monitor your whole entire stack in one place, including your serverless workloads. You can use telemetry data from any source for ridiculously cheap, and there's just one UI and all the tools you need. Plus, they completely changed their pricing to a consumption-based model so that you can easily predict your bill. Now, I love this pricing model because it scales as my cloud application scales, just like with serverless. And best of all, there's there's a perpetual free tier with 1 user and 100 gigabytes per month, totally free. You can try it and make sure it works for you before it costs you anything. So if you want observability made simple, New Relic is definitely worth another look. Check out their new platform at newrelic.com. I really do like that approach. And again, there's a lot of observability companies out there. There's a lot of log shipping companies, monitoring companies, all these different things around serverless, and they all do a really great job. I mean, for what they're doing. But I do really like this approach where you're saying, like, let's take a step back and solve the observability problem, solve the monitoring problem, but also solve sort of that operational quality and operational excellence problem. I think that's an interesting approach. So good luck with that, because I know it's not going to be easy. Like you said, like you're sort of dialing that in to get it right. But all right, so let's talk about just, I guess, monitoring your cloud and your operations in general, because this is something where we don't always go deep into this when we are talking about observability. But I guess a question that kind of comes up is, now that we're doing serverless and now that we're using managed services for a bunch of different things, what is it that we're actually monitoring for now? Like, what are those important metrics? Because if you think about it, like, I don't care about CPU anymore, or memory usage. Like, my DynamoDB tables don't tell me how much CPU or memory they're using, right? I only know like how many read units or write units I use, and as long as it's the latency is where I need it to be, those seem to be the metrics I care about. But those are different across all these different services. So what are we as a monitoring community, if that's the right way to put it, like, what are we looking for as important metrics?
Yeah, so I think there's kind of 2 answers here. The first one is that serverless is essentially like a layer of abstraction. So it abstracts away the underlying compute resources. So what we recommend our customers to monitor are user-facing things, like how fast are the responses from the backend, what's the kind of downtime and quality of the service, like how well are the users actually experiencing the system, and like that's the first layer that we kind of usually recommend them to cover. So like to have alerts on API gateways, for example, things like that. But on the other hand, it's like, what's this microservice costing you, for example, or how can you, make it quicker a bit, or like those kinds of things. So like really the impact, the business and the kind of user impact is what we mainly try to monitor. Yeah, and I think the other challenge is that just making sense of all of that data that's the system is outputting is like, if you have tons of monitoring data, then kind of trying to extract the value from that and to identify pieces where you should be really focusing on. So I think that's kind of the challenges and the approach that should be taken.
Right.
In our opinion. Yeah.
Yeah. And I think that's interesting too, from just from I guess a community or an education standpoint, that observability companies like Dashboard almost have the ability to help educate people that are using these different services on what the important metrics are. And then not only what the important metrics are, but also maybe what the baseline for those metrics should be. You know what I mean? Like, I guess the error rate on your API, you'd love to be 0. But maybe the latency, for example, like if you're connecting to a DynamoDB table through a API or API gateway to Lambda to DynamoDB table, like what that average response time should look like, and things like that would certainly be helpful. So then from a more operational standpoint, I mean, there's a lot of people who equate serverless to no ops, which there clearly is. It's clearly not no ops, right? I mean, you significantly reduce your operations, and there's many other things your operations teams could do. They could focus more on security, on automation, some of those other things. But what about the overall responsibility of some of this monitoring? So I like the approach where you don't have to instrument your code, right? So it just kind of happens behind the scenes. But where does that I guess, where does the data come in when it comes to, whether it's optimizing and following those best practices, or optimizing for costs or performance or whatever, or just monitoring the overall health of the application? Where does that responsibility fall now, right? Do you still consider, do you consider this to be a developer tool, or do you consider it to be like an operations tool, or somewhere in the middle?
I think that the trend we've seen in the serverless era is that a lot more responsibility actually falls to the hands of the developers. Not just the operations side, but also a bit on the kind of business side, or it brings developers more closer to the customers in a way as well, because the task is less on building undifferentiated value and more on actually solving the problem for the customer. And I think, I don't know if sadly or or if it's a good thing, but a lot of the operational burden also seems to fall on the developers. Like when we really talk to our users, or kind of you know are in customer calls, then we usually see engineering leads or developers, architects, uh, not a lot of operations or like DevOps people, to be honest. Like there are obviously, but I would say it's like 25%. So it's more developers, I would say.
Right.
And I think like a lot of what we do is around debugging still, and kind of improving the system in general, like security wise and things like that. And those things are kind of always done by developers, we see.
Right.
So
Right. So what that's a good point about debugging. So in order to debug your code in a, again, a cloud distributed environment, is that something where you need to be using one of these tools to do that? Is that what debugging looks like?
so yes, but I think like developers can do with CloudWatch as well. So kind of when we break it down, like there's two user stories, or kind of two ways of using. First is while you're developing and kind of iterating the application, and trying to like understand all the bugs and to fix them. Then that's something that you need to like iterate quickly, and do deployments and test it out. And like one way to do this is with us, and we do have some things like live tailing and kind of real time representation of what the activity is looking like, which may be a bit more simple than CloudWatch is. On the other hand, you can still do a lot of that in CloudWatch, or you can try to develop locally as well. We see kind of the bigger value boost in environments where that's already in production, have a lot of users, a lot of load. Then the monitoring part becomes a bigger challenge, and kind of that's where we would position us more. But we still kind of see debugging use cases as well. It's just
Okay.
that you can do a lot with CloudWatch as well.
Right. All right. So then what about the monitoring strategy? So you said that, again, you see 25% or so of the people that are jumping on your calls are sort of operations people, and then a lot more are the developers. So from a monitoring standpoint, I mean, typically you'd be monitoring to make sure that the CPU and all the servers are running, right? That's how we used to do it. And you might have an ops team that does that. So what is the strategy now? Like, so for a serverless team that's developing a serverless application, maybe there's somebody in operations that's helping with VPCs or something like that. But what is the monitoring strategy now? Is it the developers who should be in there getting those alerts, or is it still some hybrid DevOps solution that you're trying to kind of mix and match? I mean, like, how would you suggest a team use one of these observability tools so that they can make sure that their applications are running smoothly?
Yeah, if you're like going into production with your serverless application, or if you're like thinking about monitoring in general, what we kind of push users towards is really kind of set like some clear goals on like for the monitoring solutions, basically. Or like if you're building a monitoring strategy, what are the core things that you should be thinking about? And like in our case, or kind of what we see being the most important ones, first is the ability to quickly understand if there's an issue, like to quickly get notified, and to reduce the time it takes for anything happening to your development team knowing about it. And like there's a lot of things you can do there. You can map out the failure areas where you can have where you have the most risk, and then you can map out the like kind of end-to-end ways, or like monitoring API endpoints, for example, or things that are really like user-facing. Like map those out and like set alarms for those. And yeah, like the first part is really about getting notified as quickly as possible. So the second part that we think is really important with monitoring strategies, having access to the right data at the right time. So if you're discovering that something is not working, you need to have the infrastructure in place to be able to understand why it's not working, and to go through all of that data, to have that data available and to kind of show you where the problem is. So if I think those are the two main things for any monitoring strategy. And if those are clear, then it's easy to make the lower level decisions from there, like what types of data you need and things like that.
Right. Yeah, and I think that's important. Like you said something about sort of understanding where the risks are in your infrastructure, because one thing you see certainly with serverless applications is I have not seen very many 100% or applications that are 100% serverless, right? You always have some hybrid in there. You're still accessing a SQL database or a MySQL database or something like that. So that's I think something interesting is like, what do you do to sort of protect against like the brittle components? Is this something where you add more alerting and more monitoring to that, or is it something that it's just another piece of your infrastructure that you treat as just like you would anything else?
Yeah, I think it's important to be aware of those areas, like if those exist, like if you have a SQL database or some downstream service that can be easily throttled, then definitely designing around that is important, or that in mind, and yeah, treating it as a kind of a specific failure point, paying more attention, I think is necessary, and that's what we recommend to do as well.
Awesome. Awesome. All right. Well, so I guess my last question, just I love to ask people this question. The future of serverless, right? And this has been asked and answered a million times, and everyone seems to have a different answer to it. But just because again, I like how you're thinking about this approach to it. Are we going to see serverless just sort of dominating the cloud world? Like, is it just going to be the way things are? Or, well, let me take a step back, ask you this question. What's the future of serverless? What's it going to look like, 5 years from now?
So the way we see it and kind of the future we're building for is the future where developers construct their applications out of like Lego pieces, and, doing very little coding or only focusing on the differentiated value that their organization brings, and having at their exposure a lot of tools that they can just kind of piece together and use. And yeah, I think the gravity in cloud is definitely that serverless is faster to build on. The usage is based on the pricing is based on the actual usage, and it's way more simpler to kind of understand different components as well. So yeah, that's what I hope will happen. And yeah, I don't think it won't just be AWS, but it will be this entire kind of Google Cloud, Microsoft Azure. A lot of third-party services will play into it, and there will be a lot of different tools that you can choose from, but they'll all be managed and single purpose.
Yeah, no, I love that. I hope for the same thing, and I think you're right. I think the ecosystem will continue to expand. And Azure's doing some great things. In terms of what they're building out for serverless. So it will be really interesting, because having this conversation 5 years from now could be could be completely different. But anyways, all right. Well, Taavi, thank you so much for joining me and sharing all this knowledge. And I mean, again, the dashboard the product direction you have there is really interesting. It's a really cool approach. I love that idea of just trying to make sure that you implement those best practices and give people the tools to do that. So if people want to find out more about you or figure out what you're up to and find out more about the dashboard, how do they do that?
Sure. So dashboard.io is where you can contact me or our team as well. And my Twitter is at Rehemagi. So feel free to reach out, and happy to chat about serverless anytime.
Awesome. All right. Well, I will put all that in the show notes. Thanks again, Taavi.
Thank you.
And that's this week's Serverless Chat. I want to give a huge thank you to Taavi Rehemagi for being my guest this week, and to our sponsors New Relic and Epsagon. If you want to check out the show notes and a full transcript of this episode, you can find them at serverlesschats.com/75. For more Serverless Chats, subscribe, sign up to be an insider, check us out on YouTube, and follow us on Twitter, Facebook, and Instagram. You can connect with me on Twitter at Jeremy_Daily. And if you want to keep up to date on everything serverless, make sure you subscribe to the Off by None newsletter at offbynone.io. Thank you so much for joining me, and I look forward to chatting with all of you again next week.